Welcome to Academic Digest class. In today's class, we're going to be looking at chapter 11, and the topic for today is on fluid mechanics. The textbook calls it fluid statics and dynamics, but the areas I'm going to be focusing on is on pressure, density, relative density, Archimedes principle, and hydrometer device. So let's go to the first one, fluid. So I'm going to be treating this under these key concepts. Let me start with the first one, fluids. We say that fluid is a substance that deforms continuously when acted upon by a parallel force, or we say when acted upon by a shear. You know that shear means parallel force, sharing stress of any magnitude. Don't want to talk too much in this video, so I'm just focusing on what I've outlined here. Next one is fluid statics. Okay, before I move to that, they say water finds its own level. How? What that means, what that statement means is that if you have, for example, a container like this, and you have another one that is like this, and you have another one that is like this, and you happen to pour water on it, inside it, equal water. In this one, let's have something like this and this now. That's when you happen to fill all these things, that's equal. No, I think I didn't get this diagram well. This one. But when you pour water inside this thing, the same amount of water here. Let me use this two. And I pour the same amount of water here. That's when it's settled and is at rest, the two of them will come up to the same level. So we'll do experiments on that to prove it. So that is what it means by water finding its own level. So it's saying that equal amount of water, no matter the shape of the containing vessel, will rise to the same level. So that is that. Now let's move to the next one, fluid statics. Fluid statics. So simply, fluid statics is simply the study. Anytime you hear statics means at rest. Kinematics means in motion without respect to the force, while dynamics means in motion with respect to the force causing it. So that means we can have everything in physics. We always have the statics, the kinematics, and the dynamics part. So fluid statics is the study of fluids at rest and the nature / properties of fluids at rest. So if I've noted this, move to the next one, pressure. So we know that pressure is simply force per unit area. It is simply said that pressure can also be defined as stress. Pressure can also be defined as concentration. So what this thing means is that pressure is directly proportional to force, and pressure is inversely proportional to area. Pressure depends on the force. pressure does not depend on the area. Or you say a decrease in area means more pressure, and an increase in area means less pressure, while an increase in force means more pressure. What this thing means is that if, for example, I have uh, people locked up in a room, the more people I have in that place, the more concentration, yes, the more people I have in that room, the more concentration. And if that room is small, the more people I add, the higher the concentration. But let's say this thing can apply to uh, increasing concentration of things too. The more sugar applied in a particular liquid, the higher the concentration, the pressure increase. But if I have a room and I have, let's say, few people, and I now carry those few people and put inside a bigger room, I change the room and put them in a bigger room, you see that the pressure, the concentration of people there will be less. This is the same with case of liquid and its concentration. So if you add less and less, or if you remove the concentration, if you reduce the concentration, that event ends up becoming diluted. So that is the case of, let's say you have much sugar in something, eh, then you now come and start adding too much water, adding too much water, adding too much water, adding too much water. Same thing with salt. At some point, you see that it has diluted. So you take it, you need to see pressure in that regard. So pressure, when it concerns fluids, works in different ways. So the first here, they say we should prove that pressure is equals to density. This thing is rho for density, height, and gravity. So first of all, you need to remember that volume is equals to meter cube or centimeter cube. And if that is the case, area is meter square, is it not true? While length is just meter. And length, whenever I'm talking about height, length is the same thing as height. So it simply means that volume is the same thing as meter square times meter. That means volume is the same thing as area times height or times length. I've noted this. Now you need to know that force is MA. But whenever something is going up or coming down vertical, it's mg. You've noted this, Shemi? Now, if this is the case, you need to go back and remember that there's something called density. And density is equals to mass over volume. And if you remember, we can check this formula to become the same thing as making mass out of formula. It becomes density times volume. And remember that volume is AH. So mass is the same thing as saying density times area times height. So if I've noted this, I can now say, okay, right here that I have force to be equals to mg. I can come and put mass that is here to be this thing. So F is equals to density AH now times this G. So this thing that I have here, force is equals to this. I can come back to where I know that pressure is equals to force over area. So I can replace force here with this. So density, area, height, and gravity all over area. So you see that area will cancel area. So pressure is equals to density, height, and gravity. So we've proved it. This is rho. Like, it's more like you want to write P, but you're starting this one. So you can say where density, height, gravity. And what this thing means is that notice here that I have M equals to density V. If I put it here, what this means is that force is also equals to put mass to be this density V. Then remember the G here. Everything here is mass, then G here. So force can also be PVG, that is density, volume, and G, or you say PGV. So if I know this, that is that. Now notice something. The density of water is 1 gram. Hmm? That means that is 1 gram at 4 degrees C, or you say at STP. Now that means that if, for example, you need to also know that, as much as you need to know that mass of water is the same thing as the density of water. Remember that density is mass over volume, so it's directly proportional. So if that be the case, whenever you have, if this is density now, let's come back here. What this thing means is that here that I have P, this thing can be the same thing as saying P equals to M H G. Since density of water and mass of water is the same thing, 1000 kilogram per meter cube, or you say 1 gram. So it can be the same thing. And notice that this thing is looking like mgh. So we can say that pressure here is work done. So you need to know this. So in case they ask you, prove that pressure equals to work done in liquid or in water. Yeah, that is the proving. Okay. Let's move to the next one. They said here density. Remember, this is the class where I explained the concepts then before we start solving questions. So density. Density is simply mass per unit volume. What this thing means is that if, for example, I have stone and I pour stone inside 2-liter container, heavy stone inside 2-liter container, and it fill it up. Then I come inside the same 2-liter container. I now come and pour water. Which one will be heavier? This one will be heavier. So all you need to know from density is that it simply talks about the quantity of a substance contained in the same liter or in the same volume. So whenever you talk about something being dense, it means that thing has mass in a given volume. So if I have two things, so it's more like if you want to think about density, you have to think about it in terms of you comparing things. So the heavy, or should I say, the weight of a thing in a given volume is what we call density. So that is why we say it's mass per unit volume. So if I compare foam and rice, bag of rice, if I put the two of them in the same bag, rice will feel heavier. Then I will say that rice is having more density than the foam. So I want you to see it that way. So moving on, the next thing here before us is relative density. Another name for relative density is specific gravity. That's what they used to call it before. But thank God today is now called relative density more, because that's what it means. So this relative density, whenever you hear something, they say like something is submerged, know that they are talking about relative density. So relative density is given by different formulas, but it's simply you comparing the weight, the mass, the upthrust, the volume of anything to a standard substance. So, and when it has to do with fluids, you always use water. So you can say density of substance for density of water, which is D of substance all over 1 gram per meter cube, or you say 1000, or you say D of substance all over 1000 kilogram per meter cube. So relative density can also mean mass of substance over mass of water. Relative density. So when it has to do with substance, that I mean when it has to do with solids, so you can say also that relative density is also equals to mass of solid minus um, mhm, mass of solid in air minus mass of solid in water. So these are different concepts. So you can also say that relative density mhm, is, yes, so mass for solids is what I'm treating, of solids all over upthrust of solids. Or you say, let's say I use ms for mass of solids all over loss of mass in solid. Yes, all over. Yes, okay, all over displace. mm, yes, all over. Yes, all over mass of water displaced, water or liquid displaced. So what this thing means is that if, for example, I have the mass of anything in air, let's say a solid has mass 10 Newton, and then you put it inside water and it displaces the water by 3 Newton. Upthrust says that in the air, it will be denser in the air. Everything you have is denser in the air. Like when it enters water or a liquid, it tends to lose weight because of upthrust, buoyancy. I'll get there when I start treating Archimedes. So for that reason, to get the relative density of this, so let's say it displaced water 3 Newton, it will simply be the same thing as saying, or you say, let's say the weight in water, let's say the weight in water is 3 Newton and weight in air is 10 Newton. So relative density will simply be 10 Newton weight in air all over weight in air minus weight in water. So weight, or you say mass in air, or you say so weight in air, or you can also say mass in air, whichever one, all over weight in water. And this will give me 10/7. That is, the relative density is 10/7. And this thing that you see, weight in air minus weight in water, is known as upthrust. That's Archimedes principle. It's known as upthrust. So if I know this, for liquids, this is for solids. So relative density of liquids, relative density of liquids. So when you have liquids, you can also get it. And how do you do that? You say relative density of liquid. The best way to think of it is by doing upthrust of liquid all over upthrust of water. You always have to compare everything with water. Reason is because the relative density, or you say the density of water, is equals to 1. So if the T, watch, Watch, for example, if I know that, for example, here, relative density of substance, let's say density of substance is 2, here is 2, and density of water is 1, is always 1. That means that relative density is simply density of that substance. So another way to say relative density is simply to say relative density is equals to density of the substance. Since the density of water in gram is 1 gram per meter cube. Children, yes, per centimeter cube, I'm writing meter cube. Yes, since I'm using gram per centimeter cube. Yes. Let's check. Okay. Let me check something here. If I have 1000 kilogram per meter cube times 1 kilogram is equals to 1000 gram. Then I put kilogram here. Then times meter. Okay. 1 meter, 1 meter cube is equals to 100 raised to power 3 centimeter. So this is going to be the same thing as this cancel this. This cancel this. So I am left with 1 million all over. 100 raised to power 3 is something as saying 100, 100, 100. So you can see that this becomes, so this take care, this take care, this take care, this. Take care of this, take care of this, take care of this. So yes, 1 over 1 is 1. So gram centimeter cube. So this is supposed to be in centimeter cube. So I'm correct. So if you know this, so that means also relative density is the same thing as saying, if for liquid, I'm still treating liquid. So the idea of when it has to do with liquid is you always thinking of upthrust, loss in. So if, for example, I have, let's see, mass in air of liquid minus, okay, yes, mass of solid in air, mass of solid in air minus mass, okay, I'm treating liquid, what am I doing? So mass in air minus mass in liquid all over mass in air minus mass in water. This one is for practical purpose. Look at what I mean. If I have a bottle and I have the weight of the bottle to be M0, the weight of the bottle, just empty bottle, empty bottle. Then I have this bottle filled with alcohol. Then I have this bottle filled with water. If I want to get the relative density, what I will simply do is to say mass of alcohol, yes, mass of alcohol, which is M1 minus MO, mass of empty bottle. Yes. So by the time I do mass M1, because this alcohol is in a bottle, in this bottle. So M1 minus M0, it will give me the mass of alcohol. So all over this M2 minus MO. So you see that by the time I do it now, I'm left with M1 over M2. So the main thing when it has to do with liquid, what you are thinking of when it has to do with liquid is simply a situation whereby you are considering loss in liquid minus loss in water. And how you get loss in anything is simply by checking Archimedes principle. And that is the next part I'm treating now. So, measurements of relative density using Archimedes principle number 7. So, this Archimedes principle will help you understand what I mean by that loss in Archimedes principle. This principle states that every liquid, okay, it says the force acting upwards is equal to the weight of fluid displaced. So it says that when a body is immersed in a liquid or in a fluid, when a body is immersed in a fluid or in a liquid, there is a force acting upwards, and that force acting upwards is equals to, for example, is equals to the fluid displaced or equals to the amount. Let me use amount. Let me use amount instead of weight. So if I have this thing to be water and I put this wood inside, the minute this wood enters inside, eh, they will tend to be like it's trying to push this thing down. Water will tend to flow out. And if I, let's say, put a bigger basin here, eh, as this thing flows out, I put this thing, as this thing flows out, the point where water no longer flows, if I carry the water that has entered here now and measure, if I measure the water that is here and measure the weight of this particular solid or the mass of this particular solid, it will be the same with this. So it's saying that whenever you put, when a body is immersed in a fluid, there is a force acting upwards which you call the upthrust. And that upthrust is equals to the displaced fluid, is equals to the weight of fluid, or you say mass of fluid displaced, or you say amount of fluid displaced. So if I have this solid in air to be 5 Newton and it enters this water, and it displaces in this water, it displaces, I notice that what it displaces in this water, because whenever something enter water, it tends to be having less weight. I notice that what it displaces in water is like 2 Newton, is 2 Newton of weight. What it will simply be is that upthrust to U is equals to the weight in air minus the weight in water. So and remember that this one, upthrust, force, this is force. Force in a fluid, inside liquid or fluid, is called upthrust, or you say buoyant force. This is mg, remember, is equals to WA, let's say it's in A minus W like this. So anytime you are talking about loss, that means that upthrust is simply talking about loss or displaced fluid. So how to get loss or displaced fluid, loss in anything, or whenever you hear equal volume of equal volume of solid to fluid, you know that it's simply gotten by doing the one in air minus the one in water. This is the final one. But here, anytime in physics that something is bigger initially, you always do the initial minus the final. That one we normally do final minus initial is because most of the time the final one is always the bigger end of it. But whenever you notice this one now is bigger before this, so it's a principle you must stick to. So for that reason, if we'll solve the example, so you take note of this. So let's say that a solid weighs 12 Newton in air. The weight in air will always be bigger because when it enters water, it tends to lose weight because of the upward force. That upward force will make it to feel light. And we are saying that whatever it displaces, as I've put this in, whatever it displaces, if I measure this, it is simply the upthrust. It is simply equals to the amount of upthrust, the shared it you leave for this to stay. So whatever I get here is simply the weight of this solid inside this fluid. So let's say this solid inside fluid measures like 3 Newton. So the upthrust will simply be weight in air 12 Newton minus 3 Newton. So upthrust here will simply be 9 Newton. 9 Newton. So you need to note this. So, and notice there are some times when you've gotten this, you now need to do certain things on this end. It depends on the question you are given. So each of the formulas I'm writing out, you'll be taking note of it because how the question come determines what you're doing. Now, for relative, remember what we are doing. Starting from here, from this relative density part, what we are doing revolves around this number 7, measurement of relative density using Archimedes principle. So for a body that is floating, let's say whenever a body floats, so another thing you need to note is that if the weight of a body is equals to, let's say weight of a body of a solid is equals to the weight of water, or you say if the upthrust is equal or is greater, is greater than water. If the density, let me use density, I think it's best that way. So if the density is greater than water, is greater than the density of water or the density of what is entering, that body will sink. But if the density of the solid or even liquid is less than the density of water or equal to it, that body will float. So that means that everything we've been treating before now is talking about body that has more density than water or than liquid. So for example, oil, red oil will tend to float when you put it in water because it has less density than water. Ice will tend to float in water because it has less density, around 0.9, 0.8. But mercury, for example, is 13.6 times denser than water. So that means that water will float on mercury. That's what it means. So if you have less density than anything, you will float. But yes, you will float. But if you are denser than anything, yes, you will tend to sink. So that means that mercury will sink. Sorry, not yes, mercury will sink. So it's more like the one that is sinking is the one denser, is going down, and the one that is less dense tends to float. Yes, so it tends to float. So a situation where you have stone, the stone is denser than water, it is sinking. So as it sinks, it's more like water is the one floating now because it's less dense. So if a thing is denser, it tends to sink. If a thing is less denser, it tends to float. So you need to know that. So if that be the case, for bodies lighter than water, that is, remember where we are, floating body relative density. So for body lighter than water, let's say we normally use things like cork. So let me say mass of cork is mc, and is lighter. So its density is lighter than water. So now mhm, let's say mass of water is mw. mw. Then let's say for this now, to do this, we normally use a sinker. So we have mass of sinker. So we need it to, that sinker will be attached to this cork to make it to enter the water in order to get the upthrust. Then let's say this now is the mass of the sinker, mass of the sinker plus water. Mass of the sinker plus water. So when you want to check the relative density of this, the relative density will simply be equals to, so it's more like the substance is always at the numerator, while the main substance, the reference substance, is at the denominator because that's the one entering. I've told you before, the main thing is always at the denominator. So for example, if you see pressure equals to force over area, you have to have an area to apply force. If you see density equals to mass over volume, you have to have a container to have mass that you're putting it inside. So for that reason, relative density here will simply be equals to the mass of the cork in air. So mc here is simply in air, all over mass of the cork in water. So mc in water now plus mass of the sinker, then minus this one now. So this ms plus w that is here, ms plus w is simply, you've put the cork, and that's the cork, yes, the cork and the sinker. Then the cork and the sinker that you're trying to put inside. Why this one is the sinker, and water. So inside, so it will now be minus mass of the sinker plus water. So the cork itself that is in the air. Then the cork and the sinker that is used to make it enter the water. See, I have the cork when it's in air. Remember what upthrust is now. I have the cork when it is in the air. Then as it's entering, is this mc plus ms that is pulling it down. And as it's pulling it down, so it is going to be subtracted. That is to have the loss. If you remember upthrust down here, you say ma minus m in water. So the bigger one. So mc plus ms, mass of the sinker. So it's more like mass of the cork in air and mass of the sinker in air minus, this one is now mass of the sinker. Okay, let's do it this way. Mass of the cork plus the sinker in water. So mass of the cork and mass of the sinker in water. So this will be the relative density. So you can say this is mass of the cork in air mass of the sinker in air, and this one is in water. So this will be the relative density. So for floating bodies, this is how you need to look at it. Now, another principle for floating bodies, you need to notice that if that is the case, floating body principle, when you are asked when it is submerged, you now say that upthrust U is equals to um, yes, is equals to weight of water or weight of liquid displaced. So this one is when you have solid. So for floating bodies, for floating bodies lighter than water. For solid bodies, let me use for solid bodies lighter than water. You use this principle. For solid bodies lighter than water. Now, for liquid, I know you might want to be like, I'm confusing you, but you need to pay attention. Good bodies lighter, because these are big concepts and it's coming from my head. I'm remembering it. Liquid bodies lighter than water. You now need to think of it this way. Upthrust will be equals to weight of fluid, of liquid displaced. Weight of liquid displaced. So when it has to do with lighter bodies, liquid bodies lighter than water, it's still the same concept, but just that here now, you'll now be thinking of this as volume, let's see, of liquid submerged all over volume of water, or so you say volume of total liquid equals to weight of liquids displaced. That is, weight of liquid displaced is simply weight in air minus weight in water, or you see weight in liquid. So you can see this one. Okay. When I start doing example, it will make more sense. This is the explanation video. So now the next one is hydrometer. Okay, but before I do, yes, let me treat hydrometer. So for hydrometer, it still makes use of this principle of floating body principle. So for hydrometer, you do the same principle using Archimedes principle. So it uses U, that is, it does, so okay, so for hydrometer, we say that hydrometer is a device that is used for measuring the relative density of liquids, or of, yes, of liquids. It's only for liquids, so not just fluids, for liquids only. So it's a device for measuring specific gravity, or you say for relative density of liquids. So the principle you use is, you remember that relative density, first of all, the relative density is simply density of anything. If it's liquid, it means liquids over density of water. And when it has to do with liquids, you actually don't do it. Yes, this is done when it has to do with solid. So it's supposed to be density. Yes, it's still going. But when it has to do with liquids, this is valid. But in all honesty, when it concerns liquids, how you go about it is simply in a case where you now have to check the mass of that liquid in air all over, mass in air minus mass in water. So in some textbook you see this now. When you do this now, you see this thing that is here. Eh? They now tell you that if you now want relative density is equals to everything here. So if you now want to find the density of this liquid now, you can just come and say from this formula now. Will simply be this relative density that you have here. Eh? Come and put it here. Everything here. Put it here so that this will times this. This will times that is. Remember, if you carry everything here, this one is talking about density, this one is talking about mass. Carry everything about this and put here. So that if you now check it, you now have mass of liquid in air. Let me use MA all over. MA minus MW in water. Eh? I carry everything here and put here. So by the time I put everything here, if I want to get the density of this liquid, it's simply to cross multiply. So you now do times density of water. So this is a formula. I'm trying to touch everything. This is a formula you might see. So, but when it has to do with hydrometer, the working principle of hydrometer is simply you using relative density. I'm touching everything, but most of the question will always revolve around upthrust of liquid all over upthrust of water. That is you doing that RD equals to when that liquid is in a bottle, let's say the liquid is M2, M of liquid minus initial, that is when it was not measured, MO, initial mass, that is, yes, inside water or inside, yes, so mass in air, this one is mass of liquid in air all over mass of water, whatever mass or weight of water given minus ME. We'll start solving question you see. So you can now see that from here, remember that upthrust is equals to weight of liquid displaced for hydrometer. So you now see this is the sentence saying weight of hydrometer. This is weight of hydrometer, or you say W. Weight of hydrometer. The principle hydrometer uses is weight of hydrometer in water is equals to the weight of fluid displaced, or you say weight of liquid displaced. So this will be the sentence saying mg equals to weight of liquid displaced is also mg. But remember that from density equals to, this can be the sentence m equals to density v. So this can be the sentence in density vg equals to mg. This can come out as a question. You see that you have to use this and solve, or at this point you can do this. You see that this is the sentence in m equals to, if you check it, this is still density equals to mass volume. So what this thing means is that for a hydrometer, the density is inversely proportional to the volume. And you need to note that the weight of a hydrometer is constant. That is why it does not work the same way other things work. For example, if the liquid or if the fluid is denser, naturally every object tends to float. If something is denser than you will float. But if it is denser, hydrometer will tend to go in deeper. While if it is less denser, hydrometer will tend to not go in deeper. So it will tend to uh, go up or stay up. To tend to go up. So if for example, I know that this is something for this something like hydrometer. So here, this thing is lead or mercury shots. And what this thing does is to help this thing be straight in a cylinder. This one is called the stem. This is the part that has calibration. This part is called the bulb. So I'm saying that if you put this thing now in an alcohol is less denser than water. And yes, quite less dense. So if you put it in something like an alcohol, it will tend, because it's less denser than water, it will tend to like so if it's denser, when it's denser, it will tend to enter deeper because it has more to displace. Yes. While if it is less denser, eh, while if it is less denser. So what I'm trying to say in this is that from this principle you can also have, I'm coming to analyze the working principle. What I'm going to is working principle. Let me finish the formulas first. So from this place that I have this, if this is weight of liquid displaced and this, I can have this. I can also say this can be also the same thing as saying replacing mass here to be PVG, that is to be PV, that it is. This one becomes of water, volume of water equals to, this one becomes of liquid displaced, volume of liquid displaced, and G can cancel G. So why am I doing this? There can be cases, these are different cases. So if I know this, if I want to make this now, this is density of water displaced. This density of water, this is density of liquid displaced. If I want to make it in such a way that I have density of liquid and volume of liquid, I want to have relative density. Relative density is simply density of liquid all over density of water. So if I want to do this, I'll divide by volume of water. Sorry, I'll divide by, what are you even doing, this man? What is this nonsense you are doing? So I'll have, let me finish it up. I'll have TW VW equals to LVL. To make a situation that I will have this now, I have to divide by both sides by density of water. Density of water. This will cancel this. I'm left with VW. VW is equals to. So, but what I'm looking for is a situation where I have this and this one side. So that means I'll divide now by volume of liquid. Yes, I'll divide now by volume of liquid. Or you see, yes, so I'll divide by volume of liquid. So if I divide both sides by volume of liquid, it's the same thing as saying VW times 1 over VL is equals to density of liquid VL over. This will cancel this. So you can now see that relative density of a hydrometer, remember this concept was gotten from hydrometer, weight of hydrometer in water. This thing here is weight of hydrometer in water is equals to weight of liquid displaced. So if that be the case, and remember that relative density is density of liquid over density of water, which is what I've gotten here. So it's simply the same thing as saying relative density EL over W is equals to volume of of water all over volume of liquid. So that means that you can see a question and you just need to know that the relative density is just volume of water all over volume of liquid. So what I'm saying in essence is that you can have a question where relative density is just this way, or no, a question where density of liquid over density of water is equals to volume of water all over volume of liquid. So whichever one you see, that is what I'm trying to say. So back to our working principle of hydrometer. Yes, so I could have said why I got confused. I got confused because I was teaching it wrongly. Because for an alcohol, first of all, how you need to know this is that on that hydrometer, you will see something like 1.000. This is what talks about water. So anything less than water is down here, and alcohol is always somewhere around this. So you see that that means it has to sink in deeper when you are treating something that is having less density. So for less dense, the hydrometer goes deeper. It goes deeper. So I will have a class for just hydrometer. Why for denser, the ones that are denser, it tends to go low. Tends to go low. So it tends, if it's denser than water, anything denser than water, it has less to displace. It has less to displace. So for that reason, the hydrometer will tend to float up. It is designed, this hydrometer is designed to always float. So it's not like an object that is going to sink at any point. No, it doesn't sink. It's designed in such a way that it will always float. So if you have a less denser material or less denser liquid, is only working for liquid. For less denser liquid, it will tend to go in deeper. Always use alcohol to note it. I said that alcohol is less denser than water, so it will tend to go in deeper in order to get the reading of the alcohol. But if it is a denser one, it tends to just move up. So I'll still make a video on working operations of hydrometer. Just you can neglect that part. I'll make a video on it. Please subscribe to my channel.